Today we are on our last unit of the year. This is the second part or section of statistics. It's about summarizing and describing data. We talk about that today. But before that, about end of the unit, you are supposed to do your, finally we are here and we are done, by the way. So statistics is our last unit of the year. So you are going to do with your partner of your choice and present presentation on statistics. First, choose a statistical question that is answered with quantitative data. Second, calculate the measure of center. We'll learn about these measures of center today and argue which works best for your data set. Third, calculate standard deviation and IQR to describe the spread of the data you have. We'll talk about this today. Create a box plot and histogram to represent your data. We'll also learn about this. Have a video or audio or PowerPoint telling us about your data and what you have learned, but you should present something visual on your presentation. So it is good to start thinking about these things early, and you can work on it as we go through the content. Okay, measures of central tendency. These are the measures that indicate the center or middle of the data. You know those even from earlier grade. Mean, median, and mode. Mean is the average value of data. To find that, you add all the values and divide by the number of values. Median is the middle value. Mode is the most frequent value. Okay, as an example for the first one, say if I have those 6 data sets or data values, you can add those and divide by 6 to find the mean, okay, which is 47. Some questions might be like finding the missing data set. Suppose you know your average was 10, but you lost one of the numbers of the 5 numbers you used. For instance, call it x. So to figure out that x back, that number which you lost, which you missed, 5, 8, 10, 12, what we do to find the missing number when we know the average. There are 5 values, but we know 4. What we do is we add those 4 values plus x divided by 5, which is 10, and then multiply 5 by 10, which is 50. Now the 4 values add up to 35. So 35 plus x is 50. So x should be just 50 minus 35, which is 15. So this is some type of one type of question in mean, or in finding average or finding value from missing value from the given values. To find mean, first we arrange the values in ascending order, smallest to the highest value. If you have odd number of values, you just take the middle value. If the numbers of the data are even, then you add the 2 middle values and divide the sum by 2. But for odd data values, just you take the middle one. For instance, these are 5 data arranged in order, in ascending order. The middle one is the third one, 40, so that would be the median. But if I have 6 values, since these 2 are in the middle, the average of the 2 would be our median. 40 plus 50 divided by 2, which is 45. This is our median. So we need to know if the data set odd or even. We have to identify that. Okay, data distribution is a function or a listing which shows all possible values or intervals of the data. That is, say you have the data values and how often each value is occurring, meaning data value in terms of the frequency. This is called just data distribution. There are 2 types of data distributions. Basically, a normal distribution shows data that vary randomly from the mean in the pattern of a bell-shaped curve. A skewed distribution is a distribution whose shape is stretched out in either the positive or negative direction. This depending on how many data values are in the center. If there are many of them in the center and uniformly spread out, to the both ends, to the left or right, it will be called normal distribution. For instance, this is equal amount of data to the left and to the right, so many data values are accumulated here. This is a bell shape. This is called normal distribution, bell curve. Skewed left or negative means less data spread out to the left. It is negatively skewed. Many data values are at the right here, but only less values, or it has long tail on the left side. This is called skewed left or negatively skewed. When it is skewed right or positively, less data spread out to the right. Many data values are at the left, so less data values to the right. So in this case, in the normal distribution, mean would be the good measure of center. But when we have skewed distributions, the median is always in the middle of mean and mode, and so median would be the best way of finding the center of skewed distributions, as we stated it here. For normal distribution, and when there are no outliers, meaning no very small values in the data, or very large, which are extremely away from most of the data, in that case use mean. Yeah, but if there are outliers and if the data is skewed, we use median as our best measure of center. Data presentation. Now, that much said about center or measure of center. Data can be represented in different ways. The method of summarizing and presenting data is called just data presentation. In the study of research or statistics, one of them is a bar graph. This can be vertical or horizontal, and it is a visual representation of data including series of separate vertical or horizontal bars representing numerical amounts. So variations in the length of the bar allows for quick comparison. The length of the bar tell you how many or how many data values are represented by that bar. For instance, here, say a bar graph, this shows number of people who chose their favorite type of dancing. Say about 58 people chose cinema, about 22 people chose plays, and about 21 chose art galleries, and so on. So this represents this is a bar graph where there is a separation between the bars. The bars are not that tight to each other. That's the main class differentiation, or how you differentiate a bar graph. When it is histograms are a special form of bar graphs where data represented by these histograms should be continuous rather than discrete categories. When we say continuous, that can be represented with decimals and even fractions, not discrete numbers, discrete integer numbers. Say the bars are attached to each other, the other condition for histogram, instead of separate ones like the bar graphs. So continuous category may have a large number of possible values, and the data are often grouped to reduce the number of data points. These are used to reduce the amount or the number of data points we have. For example, instead of drawing a bar for each individual age between 0 and 65, the data could be grouped into series of continuous age ranges such as 16 to 24, 25 to 34, 35 to 44. Like this, unlike the bar chart, you can create a large data points into systematic or summarized way. This is histogram. Let's take this example. For instance, this histogram shows a percentage of men spending at least 1 hour per week in sports or exercises by age group, say between 16 and 24. 62% of them. Between 25 and 34, there are 42% of them, and so on. So the bars are just attached to each other. It's continuous, unlike the bar graph. So, second example, for instance, heights of 30 people are given here, heights in centimeter, and frequency, how many people are in this height range. Say there are 6 people with heights between 139.5 to 149.5. There are 9 people with the heights between 149.5 and 159.5, and so on. So if I want to find the percentage of people with heights between 139.5 and 145.5, I divide the 6 people by the total number of people, which is 30, and multiply by 100, which is 20%. So 20% of the entire number of people fall in the heights between 139.5 centimeter and 149.5 centimeter. Okay, this is the second presentation, or the second how we present data using histogram would be the second way. Third one is scatter or dot plots. Scatter plots are used to show the relationship between pairs of quantitative measurements made for the same object or individual. For example, we can use a scatter plot to present information about the examination and coursework marks for each of the students in a class. Suppose, or another example can also be used. This example, for example, shows the relationship between children's age and height. Age 8, the height is approximately 115. Children of age 9, on average they have height of 120, and so on. So if we try to list values, or trace back the values of this dot plot, what we do is 8, 15, age, height. If we go 8 and 115, 9 and 120, 10 and 128, 11 and 130. So we can trace back the data values from this dot plot. This can be done from histogram and the like too. Okay, pie graph is usually a visual way of displaying how the total data are distributed between different categories. Usually we use a circular region divided into showing the categories are in how much of the total. For instance, if we use data that are classed into different categories, it should be small number of data values. If it is very big, it would be very hard to represent. It's possible, but it would be very tiny, the classifications or the subdivisions. So for instance, distribution of visitors amongst the most popular types of tourist attraction can be, for instance, those people who visited historical and monument might be 15%, wildlife parks and zoos might be only 8%, and so on. Museums and galleries for 2%. Like that, you can use pie chart. Measures of spread. We go to measures of spread after how we can present data using bar graph, histogram, or dot plots, or pie chart. The other measures of spread, the other measures in statistics are measures of spread. These are those measures that show how much the data values are spread out or closest to each other, to the mean, and also to each other for that matter. So these are mainly 3: range, interquartile range, and the standard deviation. The range is the highest value minus lowest value, as you know it. Quartiles are values that separate a finite set of data values into 4 equal parts. So the first quartile is the median of the lower half. It contains 25% of the data below this mark, which we call first quartile, median of the lower half. Second quartile, or Q2, is the median of the data, which divides the data into two equal parts into 50%. The third quartile is the median of the upper half, which below this are 75% of the data. Okay, we'll see the interquartile range. The other measure of spread of a set of data values is the difference between the third quartile and the first quartile. Okay, the higher or the bigger the range, or the bigger the interquartile range mean, the data are wide or spread out from the mean, or there is a big variation between the mean and the values. Okay, IQR, or interquartile range, Q3 minus Q1. Okay, the 5-number summary mean, it includes these 5 items. The 5-number summary, when we say you take the minimum of value of the data, the first quartile of the data, the second quartile or the median, the third quartile, and the maximum value. These are what we call the 5-number summary in statistics. We can put this also in a diagram form, but the values must be first in increasing order. This is what is called box and whisker, or whisker plot. This is a diagram that shows the 5-number summary. You have this bar here showing the smallest value, this box here for this bar for the first quartile, for the median, for the third quartile, and for the greatest value. This is just another way of representing your data on a diagram form. Okay, let's take an example. Consider the following data set. We have that. This is a 5-number summary. Find the range and IQR, or interquartile range. Draw a box and whisker. Okay, so first you need to rearrange this in ascending order. We have that. To list the 5-number summary, we need to find the mean, the max values, and all the 3 quartiles. So we first arrange it. As you see, after you arrange it, the mean is 3, the max is 21 clearly. The median is 12, that is the fifth value in the middle of the 9 values. 12, the middle one, median. Now if I want to find Q1, I need to find the median of the lower half. Here, the median of the lower half, 3, 5, 7, 8. The median is 5 plus 7 over 2, which is 6. Really, 6 is the 25% of the data are below 6 here. The 50% of the data are below 12, and the other. That means it divides. This is Q1 is 6. Q3 will be the median of the upper half. The upper half is this, 13, 14, 18, 21. And the median of that is 14 plus 18 divided by 2, which is 16. So the 5 numbers are the mean, the max, and the 3 quartiles. So the 5 number summaries are the following: minimum 3, Q1 6, Q2 12, Q3 16, and the maximum 21. The range is the max minus the mean, which is 21 minus 3, or 18. The interquartile range is Q3 minus Q1, which is 60 minus 6, which is 10. The box and whisker plot would be this one. As you see it, 3 corresponds to the minimum, to the left end of the box. Here, this is 6. The median is 12. And this is 16. Yeah, we can put this 6 actually here, then the 16 there, then on it up there. Yeah, this will give you the 5 number summary and its box and whisker. how to find them. But first we need to know how to find, after you find the median, find the median of the lower half, that will give you Q1, and find the median of the upper half, that will give you Q3. Okay, the last one we see would be the standard deviation, which is for standard normal distribution. This is used for a comparison of values across different data distributions. So the main one is what is called standard deviation, or S. So standard deviation is a measure of how much the value in a data set or deviates from the mean. So this measures how much each data value differs or vary or deviate from the mean. The smaller standard deviation is the closer the data values are to the mean and to each other. The larger standard deviation means the data values are spread out from the mean and from each other. So that is the main distinction, or how we check data values are closer to the mean or to each other or spread out using standard deviation. For instance, here the owner of an apple orchard and the owner of an orange grove create histogram to display fruit production data here. Say the mean for the apple trees is 1750. The mean for the orange tree yield is 210. Describe the shape of each distribution. Discuss how the distributions are alike and how they are different. They are alike since both of them are having normal distribution or just bell-shaped, and also the mean of each of them is almost in the middle. The mean values for each of them is in the middle. That is a similarity. But if we see the standard deviation of the apple tree yield is 296, but that of the orange tree is 210. This one has bigger standard deviation, meaning the data values here are more spread out from the mean than the data values for the orange tree yield. So that tells us that. Okay, steps to calculate standard deviation. How to calculate? To calculate the standard deviation of set of values, first find the mean, the simple average of the values. Then for each value, subtract the mean and square each result. For each value, we'll subtract the mean from each value set, from each value of the set, and then square each of them. Then find out the mean of those square differences, meaning divide the sum of the square differences by total number n of the values. Then take the square root of the result of step 3 and you are done. That will give us standard deviation. So yeah, it is the difference of the squares from the mean, and so it would be a good approximation how much data are spread out or closer to the mean and each other. Let's take short and simple example here. Sam has 20 rose bushes but only counted the flowers of 6 of them. The population is all 20 rose bushes and the sample is the 6 bushes that Sam counted the flowers of. So let us say Sam's flower counts are 9 from the first bush, 2, 5, 4, and so on. There are 6 counts there. Find the standard deviation. So step 1 is using sampled values, those values, to find the mean. Add, divide by 6, you get 6.5. Usually we use X bar for mean, to mean the mean of a data, X bar. This is a little bit the left, but should be on top of X. Then step 2 is for finding standard deviation of those numbers. Then for each number, subtract the mean and square the result. the mean was 6.5. I subtract from each value that mean and square it, and this is going to be added. Step 3 is then work out the mean of those square differences. The mean of squared differences, these are squared differences. We add them and divide by n, which is by 6. The sum became 65.5. If you divide it by 6, it will be 10.9. So standard deviation would be square root of this, which is 3.3 would be standard deviation. So on average, these data values deviate from the mean, which is from 6.5 by 3.3. Okay, there is a general rule or formula for finding standard deviation. This is the formula. This S means the standard deviation of a sample. This symbol sigma means sum of x minus x bar squared. That's from each value, take away the mean, square it, and add them, and then divide by n, take the square root. Yeah, this ends the lesson for today and for the year, and I hope you will be doing your assignment, and also in the next 2 weeks you will do your project. Don't forget that. This is the end of this year's lesson. The few remarks which I gave about the end of the last unit is also given on your PowerPoint. Wish you good luck. Thank you.